Hi class. The purpose of this video is to assist you in completing the fossil Webquest, where you have questions to fill out, and this is the website that you will be using to do so. So what I'm going to do is go through each part of this website with you and read the content aloud. We want to start by looking at the right-hand side of our screen where it says Student, and you want to click on Level 1. So it says, welcome to Getting into the Fossil Record. This animation shows how a dinosaur can get buried by sediment after it dies, becoming a fossil and then become exposed. The fossil record holds important clues about life in the past, but not everything that once lived gets preserved as a fossil, nor do all fossils survive Earth's forces. In this tour, you will learn about the fossil record and how fossils are formed and found. Let's begin by learning what a fossil is. I'm going to click Next. Fossils are remains or traces of ancient life. All of the fossils that exist, whether dug up or still in the earth, provide us with a record of the history of life on Earth. This is called the fossil record. Paleontologists are scientists who use fossils to study life in the past. There are many questions in the fossil record that can help us answer. Click here to see a few of the options. Notice how this changes color. That means I can click on it. What types of organisms existed in the past? How did organisms move about? Fossils can be body parts of ancient organisms such as bones, shells, teeth, or plant leaves. Below is a picture of the fossil of an ancient amphibian's body. You can see its skull and other bones from its skeleton. Click on the fossil to see a slideshow of several other body fossils. Trilobite, dragonfly, ammonite, plant leaves, acorn, fish, marine invertebrate, baby dinosaur, trilobite again. All right, we're going to go to next. Fossils can be traces left by an organism, such as burrows, coprolites, which is poop. Feces means poop. Tracks and trails, nests or footprints. Below is a picture of a fossil of a footprint. This footprint is the trace of a dinosaur that walked across a mud flat long ago. Click on the fossil to see a slideshow of several other trace fossils. There are many different types of fossils. Some fossils are both a trace fossil and a body fossil at the same time. This piece of wood was chewed by a beaver before it became a fossil. It is a body fossil of the wood and a trace fossil of the beaver. Feel free to pause this video at any time, or you can rewind it or fast forward it if you need to. Most fossils are formed when organisms or their traces are buried by sediment. Layers of sediment such as sand and silt cover the remains of the organism or its trace. Eventually, the layers may harden into sedimentary rock, trapping the remains inside. Burial is important for protecting the organism or its trace against destructive forces. Let's stop and think here. Which organism do you think is most likely to be preserved? Now we know that organisms will begin to decompose. And what causes living things to decompose, which will happen to us eventually when we die, are tiny organisms like bacteria, and they break down our body. So which do you think would most likely be preserved? One that gets buried quickly, one that gets buried slowly? If you said A is correct. Fast burial protects the dead organisms or traces from being destroyed by scavengers. So these are animals that will eat the organism. Maybe it's food for them. And decomposers, which we said are bacteria. We can click on this too, if we would like. So it says a decomposer is an organism that breaks down tissue and or structures of dead organisms. It also protects them from physical factors. So the fast burial protects the remains from physical factors like waves, wind, rain, and the sun. All of these things can cause weathering and erosion to happen. And those things will destroy the organism. They're going to break it down, grind it up into little pieces, and then we wouldn't have an organism, or it wouldn't be able to be made into a fossil because it's broken apart. Even if an organism is buried, there is no guarantee that it will fossilize. Have you ever picked up a handful of dirt and found all sorts of worms and other living things crawling around? Many types of decomposers live in the top layers of soil. These decomposers can break down dead organisms before they harden into fossils. We don't want that to happen. If we want something to become a fossil, we don't want the bacteria or weather to get to it. Once an organism is buried, there are several ways it can become a fossil. We can click on these pictures. Molds of fruits, casts of fruits. Molds are imprints left from something that was buried. The structure decays and its imprint or mold is left in the sediment. The mold can be seen if the rock is broken open. Casts are formed when the sediment leaks into the mold and hardens to form a copy of the original structure. So in order to form a cast, we have to have a mold first. Okay, so we have an imprint, then sediment will get into the mold, get into that imprint, and eventually form into rock. Mineralization occurs when minerals carried in the water built up in the spaces of an organism and eventually become rock. Leaves are among the most common preserved fossils. Here we have dinosaur skin, an impression. So this is a mold, dinosaur skin. Look at the little bumps. We can also have tiny fossils called microfossils. This means millimeter. That is a very small measurement. In each of these examples, the organism was buried in sediment. But does an organism always have to be buried in sediment to become a fossil? Now, we didn't discuss this yet, so you might not know. This is a guess. I'm going to say no. No is correct. So we know that organisms can be buried under sediment to become a fossil. That's one way they can do that. But there are other ways in order to preserve the remains of the organism or any impressions left behind. Not all fossils are formed by being buried in sediment. In rare, this is not common, rare means not common instances, an entire organism can become a fossil. So one way is if it's frozen in ice, like in a glacier. We have mammoth fossils. We have some hairs of mammoth fossils, some hairs of mammoths that we found. Or it can become in a tar pit, preserved in a tar pit. Tar is like what is used to make roads. Or it can be it can be trapped in amber, which is tree sap. And amber is also another word for like a brownish color. So tree sap can harden and preserve in fossils, such as an insect. So amber is good at preserving tiny things. It wouldn't be able to preserve a whole dinosaur. That wouldn't happen. But it can preserve tinier creatures like insects. Some structures are preserved in the fossil record more easier than others. So what do you think would cause an organism to become a fossil, to better become a fossil than another type of organism? So First type is if they have soft parts like skin and muscle and cartilage. Other organisms have hard parts like bones, teeth, shells, and wood. Okay? If an organism has soft parts, these decay quicker. The hard parts will not decay as fast. So those that have hard parts are more likely to become a fossil. Which do you think are more likely to become a fossil, hard parts or soft parts? Well, it's hard parts because they don't decay as fast. So we don't want it to decay. We want to kind of slow that down from happening. We want to catch in the process. So those soft body parts like cartilage, which is in your ear and your nose, skin, muscles, those will vanish away much quicker than your teeth and your bones. That's why when we find skeletons of people, what's left is the bones. We wouldn't find, and teeth. In some instances, we wouldn't find any sort of tissue like skin. Hard parts are more likely to fossilize than soft parts. Oh, that's what I just said. So they are also less likely to be destroyed. So they are tougher, so wind and rain and weathering, they are able to withstand that more so than the soft body parts. However, in rare instances, soft body parts can be preserved in amber. So that tree sap, that brown tree sap, that hardens. Over time, it's going to be as hard as a rock. Where an organism dies helps it determine whether or not it becomes a fossil. So we have some ocean environments. They are good for fossilization because sediments are brought there and they form layers quickly. Lakes have a better chance of becoming a fossil, so organisms that die near a lake or any other aquatic areas like rivers, swamps, deltas, lagoons. Rocky intertidal area, so ocean organisms here have a low chance of becoming a fossil because we have constant waves hitting it and they break that apart. So here is not a good place to form a fossil. Another good place where fossils probably won't form is the rainforest. So rain causes the rapid decay of dead organisms. That means they're going to break down. We also have a lot of animals here, okay, that like to eat it. Okay, so rainforests will not be a good place to form fossils because once that organism dies, it's going to be decomposed, right, by those bacteria. Something else could eat it, or the rain could wash it away. You just learned that not all organisms have an equal chance of fossilizing. What are the important factors to consider? Avoid scavengers and decomposers. B, having hard body parts. C, dying in the right place. Or D, all of the above. If you said D, you are correct. The fossil record is not complete. Click on the pictures to find the right. Click on the pictures to the right to find out why. All kinds of organisms live and die in their own environments. Only some remains of organisms that die resist destruction from physical and biological factors. Of those that remain, only a few will resist destruction long enough to become fossils. Of the organisms today, this is a guess, what percent do you think will eventually become fossils? Which do you think? I did not know. When I answered this question for the first time, I guessed. I said less than 10, and I was correct. In the next video, we will finish the rest of the Webquest. So if you can see on the left, this is what we completed, 1 and 2. We have 3, 4, and 5 yet to complete. So the next video, which will not be as long as this one, will cover these last topics, which you can listen to help finish your fossil Webquest questions. Okay, so stay tuned and please click on the next video to hear the rest.